So, hello everyone. We are here to discuss the problem of the day. The question that we have today is maximum sum combination. Let's read the question. The question says, given two integer arrays A and B of size n each, a sum combination is made by adding one element from array A and another element from array B. Okay, what do we have to do? We have to return the maximum k valid sum combinations from all the possible sum combinations. Okay, and there is one note given. It says output array must be sorted in non-decreasing order. Fine. So what is the question trying to say? Well, the question is saying you will be having these two arrays, okay, namely A and B, right? And n here in your parameters, n is your size and k is how many valid sum combinations that you have to return. So what we have to do is we have to pick one element from A and another element from B. We have to add it up and we have to keep on making these combinations. Once we have all the combinations, what we have to do, we have to return all the k valid sum combinations which are maximum. Okay, and we have to return them in the form of an array which is in non-decreasing order. It'll be even more clear once we see the examples. So here are the examples. Let's solve it by ourselves. Okay, so these are the same examples. What do we have to do? Firstly, we are given the size and the number k, and these are our two arrays. Fine. So what could be the possible combinations? Okay, let's try making that. Assume I pick this 4 and 3. What will be my sum? I pick this 4 and 3. What will be my sum? It will be 7. And if I pick this 2 and 1, okay, what will it be? It will be 3, correct? Now I pick this 4 and 2. This 4 and 2 turned out to be 6. And then I have 1 and 3. 1 and 3 turned out to be 4. Okay, k is 2. That means we have to return top two sums. And what are the top two sums? I can see here, I have 7 and I have 6, right? So we have to return this array. Okay, seems simple. Now take a look at this example. Okay, now we have arrays of length 4, correct? So now what we have to do, we have to make up combinations, right? Okay, so we have to go a little smarter because we cannot keep on making all the possible combinations because that is naive method, right? So what we can do is we can pick up the maximum values of the arrays. So I can see this array has 6 as a maximum value, right? So I said 6, and which is the maximum value from here? We have 4, right? So combining these, I formed 10. And we all can agree that 10 is the biggest possible sum, right? But how many sum we have to return? We have to return top 3 sums, correct? So we have to pick out more pairs from it. Nextly, we can take 6 and 3, right? 6 plus 3, that could be 9. And then we can take 6 plus 2, but notice something here. I can take 6 plus 2, but it will be 8. And if you notice carefully, we do have one possibility of 5 and 4 as well, which also results in 9, correct? And no matter any pair that we make after it is going to be less than 9, 10, 9 and 8, correct? Because we have already used up the big values. We have to return top 3, and these possibly are the top 3, correct? What are the combinations? 6, 4, 6, 3 and 5, 4. What do we have to return? We have to return this. So an array composing of 10, 9, 9, right? So I believe now the question statement is clear to you. Now let's discuss the approach, how we can approach this question. Well, first of all, thinking about the brute force approach, it is really common. What do we have to do is we have two arrays. One is A and another is B. And what do I have to do? I have to make all the possible combinations. How do we make all the possible combinations? We do that using nested loops, correct? For I in your array and for j in your array, and we have to make up combination of all these. So once we do that, we have to take all the combinations. We have to create sum of every combination, And then we have to sort the array of sum that we make. So assume, let's take a smaller example. I said I have 2, 5, and I have 3, 7, right? This is my array. What do I have to do? I said for I in A and for J in B. I have to keep on adding I plus J, and that will be in one of my variable called sum, and I will have one list answer, and I'll keep on appending here. I'll keep on appending my sum in this array. Okay, so I'll do something like that. So what will happen at the last is I'll have one list, or you can say an array, which will be containing all of my sums, correct? And after that, I can just sort that. Once that will be sorted in descending order, what do I have to do? The next thing I have to do is I have to return the first k elements, correct? Seems simple, but again, we are doing so much extra work. We are making so many pairs which are actually not of any use to us, correct? So just to overcome this and just to reduce the time complexity, because if we talk about the complexity of the brute force, it is going to go till n square, right? It is going to go till n square because we are using this nested loop. Fine. Now let's see a better method for this, or for the same thing. So once we talk about the optimized approach, what we actually will be using is one heap. Okay. And talking specifically, we'll be using max heap. What is the property of max heap? Well, it is a sort of binary tree with such arrangement that every time at the root node, we always have the biggest value. Fine. So what do we have to do? We have our A and we have our B, correct? Well, the intuition says that why not we sort them in descending order prior to putting a logic. So once we sort both of these in descending order, then we'll be having all the biggest values here at the beginning, correct? And then what do we have to do? We have to start making up pairs. We have to start making up pairs. Let me take one example here. So here are the two arrays. What is the first step? We have to sort them in descending order. So if I do this, it'll be 4, 3, 2, 1. And doing the same thing with B, I'll have 6, 5, 2, 1. Okay, so we have done that. Now what do we have to do? Well, first of all, this you can say is the corner case, or you can say it is a compulsory thing that we have to keep this pair. Why? Because this is obviously the biggest value. So what I'll do is I will have one heap. I'll have one heap and I'll put this value here inside this. And what will I put? I will put the sum. Okay, that is your 6 plus 4, 10 for this one. So I'll be putting 10 now along with it, because I would not want that this value should be repeated when I'm making pair and when I'm implementing my logic. I do not want any pair to be repeated. Fine. So just for that, initially what I'd say, I'd also send its indexes. That means what pair I've made? I've made pair of 0, 0. All right. I'll push this value inside my heap. I'll push this value inside my heap, and obviously the heap is being formed according to my sum. Now what do I have to do? I will also keep a track of this. Well, first let's make more combinations. So it'll be clear in your head. So if I hold this 6 this time and I make the another combination with 3, correct? Similarly, the other time what I'll do, I'll hold this 4 and I'll make a combination with 5. So similarly, the next time what I'll do is I'll hold this 4 and I'll make the combination with 5, right? So the combination that I'll have will be 6, 3 and 4, 5. Correct? And just to notice, we will always be doing this. We'll be making combination of the just adjacent indices. We won't be making combinations of 6 and 2 and 6 and 1, because we know clearly that these are really far away and this combination is not going to be giving us the fruitful answer. Although we will be making it till the end, but every time we do, we will just make combinations of 6 and 3 and 4 and 5. That means the first two indices. After that, in the next iteration, what we'll do, we'll make combinations of these 3, 5 and 2, 2, which the combination will be 2, comma 3 and 5, comma 2. Correct? And the other time, what will happen? I'll do the same thing here. I'll make combinations of these 2, comma 1 and this 1, comma 2 and also this one whenever needed. But it depends on us and how many values do we have to return. The similar logic will be happening. We do not have to make combination of the extreme values. We just have to make combination of the adjacent values. Okay. So now let's see what will be happening next. What do we do with these values? Once we have 6, comma 3, which actually is resulting in 9. What do we have to store in our heap? We have to put this 9, right? So once we put this 9, along with that, what are going to be the indices of the same? Well, talking about the indices, when we are having 6 and 3, I have 1, comma 0, right? I have 1, comma 0. Let's talk about 5 and 4. 4 and 5. The indices will be 0, comma 1. Okay. So thus we know these are two different 9s. Okay. One thing more, how do we keep track of that we are not doing the same thing again? Well, very simply, we can create up a visited set, right? Just to removing the redundancy. And we'll only be inserting in the heap once we are confirmed that we have already not made this combination before. So once we make this combination, I'll also put that inside my visited array. Okay, inside my visited set or array, whatsoever you want to take. So you'd be putting that inside your visited, and you'd be making the call for insertion in the heap only when this is passed. That means we have not visited it before. We have not made this combination before, right? And continuously what we'll be doing? Well, in the beginning, we'll enter the maximum value. That's for sure. Then every other time we make one insertion, we're actually going to pop the heap because we know we are taking up the maximum values, right? And the next maximum values are going to be from these combinations. Okay, let's see the implementation of this code and then it will be even more clear to you. Here's the Python implementation of the same logic. Let's see what we are doing here. Well, I have used classes and I'll walk you through the code, how it is working. So here what I've done is I have used this class. I have named it as find max sum. What I've made one constructor. I have made one element. This element is for adding something to the heap. Okay. And this element is for making the combinations. Fine. So what I'll do initially, so I've made this object of this class here and I've passed on A and B. Now what is happening in the constructor? I am storing these A and B as sorted and reverse. That means I have sorted both the arrays in descending order now. What is the next thing? I've created two more variables. One is sums that we need to store. Another is visited. Okay, and what is visited here? Visited is set. And sum is going to be the complete list. So we are going to be storing all the sums in it. Fine. And what I've done here is I have called this member function here. And the name of the member function is add element. That means I'm talking about this one. And initially what I'm doing, I'm adding the 0th and the 0th element. That means the biggest values. Remember, once we sorted the arrays in descending order, the 0th and 0th index were actually having the biggest values, correct? So that is what we are doing here. We are adding the first elements. So once I am saying self.add element 0, 0, I'm here and it is receiving these 0, 0. I have put that in indexes. Now I'm checking that my index of my A, okay, IA is actually inside the bound, that I'm not exceeding the array. I'm doing the same thing with B. I'm saying just it is inside the bound. And this is the main thing. I'm checking that this is not already made. Okay. For the first time when we are showing the maximum value, this won't be of any use, but we have designed it so that our logic works for the furthermore combinations as well. So what is happening here is index is not in visited, just we have seen before. What I'm saying here is I have to check my visited set and I'm just checking that these indexes, the combination of IA, IB is not already existing in visited. So once all these conditions are passed, what do I have to do? I have to push the values. How am I doing that? I'm using the inbuilt heap. So heap push will actually pushed the sum here. What is my sum? It is actually my list. Okay, so inside this list, I'd be dealing this list as my heap. So inside that, what do I have to fill? I have to fill my values. I have to fill my sum, comma, indices. Just like what I told you, something like this. We have to fill up this. But one thing that you have to keep in the Python implementation is the heap queue by default produces always min heap. So what we can do to convert it to a max heap? Well, a little trick is we can use negative numbers, right? We can use negative, we can multiply every number with -1 so that the whole tree that is made, the whole heap that is made will be actually max if we just see the values, right? A simple mathematical logic. We have the biggest value here, which is actually the negative, once negated, it is going to be the smallest value. Okay, so if you have to store 10, that is going to be the maximum value for your max heap. I'll actually store -10, which will actually be the most minimum value of the negative, or you can say minimum heap, right? So just a little trick here that we are playing. Once that is done, and here what I'm doing, I'm taking the first value. Let's take the same example. I'm taking 6 here and I'm taking 4 here. What I'm doing, I'm saying -6 -4. That means I'm storing -10. -10 comma, what are the indices here? 0 comma 0 initially, right? This thing will be pushed inside my heap. Fine. Now see what I'm doing here. I've composed one list, right? I've composed one list, and this will be working for k times. And what we are doing here, I'm calling this retriever function. Well, actually, once I make a call on the object, it'll actually be calling this function. Okay, and you know what this function is doing? This function is making up the combinations of the adjacent values. So the very first thing I have to do is I have to pop the value. I have to pick the value which is at the top of heap. I'll pick the value and I'll return that. See, the value that is returned from here is actually going to appended in this array. So once I have this, once my heap pop is done, what will happen? I'll have my sum here in this and my indices here in this variable. Indices will be now shared to IA and IB again. Now this is how I'm making the combinations. Okay, let me draw it for you. Okay, so this was our example. What we are doing here is the first one is compulsory. We have taken 10, right? We are done with it. We have already stored that in this array as well. What is the next thing that we have to do? I have to add the element. That means I'll be calling this function again, but what are going to be the indices parameters? It is not going to be 0 comma 0 now. Now it will be 0 and 1 and 1 and 0. Okay, for the first time, I'll increase this. That means let's see from this example. First combination is going to be 6 comma 4. The next example, the next combination is going to be, I'll be holding on to 6. I'll be increasing this index, and I'll be sending 6 comma 3. And the other time I'll be holding my 4 and I'll be sending 4 comma 5. How it will be done? It will be done by adding 1 to B for the first time and adding 1 to A for the next time, right? Both of these things are made. Again, this function will work in the same manner. It will check that we have not already made this combination, and if not, what I'll do, I'll put that sum comma indices in the heap, correct? And also add the indices in visited. And this will keep on happening. How many times? This will keep on happening k times. Eventually what we'll have is, we will have this array which will be storing k popped values. Remember how many times we are doing this? We are doing this k times. What is actually happening? K, it is getting popped k times. My heap might have values more than k, okay, but it is getting popped only k times. And what I'm doing here is I'm returning negative lnum. Okay, negative lnum. Why do I have to return negative lnum? Because the popped value that I'll be having will already be having one negative, right? One minus sign in front of it. So what do we have to do? We have to do it like that, so that minus minus becomes plus, and this is the positive value that we actually have to return, right? So this is how I'll be making up this array. And for this example, 1099 will be the answer, as we've already seen. Okay, let's talk about the complexity here. So because heap is also a binary search tree, what will happen in insertion? It will maximum take log n, correct? The maximum time it can take is log n. And in the worst case scenario, how many insertions will we be making when k is equal to our n, right? So we'll be doing log n work n times. So it will be n log n. And if we also consider that we are sorting, right? So we can say that n log n for sorting as well. Eventually, what we have to do is n log n plus n log n, which will nearly be bigger of n log n, correct? So I hope you understand why this complexity is there. Let's try running this code and see if it is working against the test cases. Okay, so here we have the same code. Let's compile that. Okay, it is giving us the expected output. Let's submit it and check it against all the test cases. Okay, so it is passing all the test cases. So I hope you have understood this problem. Thanks for watching.